All right, so let's fill out one of our learning cards on z-scores and normal distributions. So we're going to start off with this one by saying if it is normally distributed, if we have a normal distribution, then we can answer these types of questions. It says PSAT scores are normally distributed with a mean of 500 and a standard deviation of 85. So the first thing I want to do is I want to make note that the symbol that we use for mean is mu and the symbol for standard deviation is sigma. Knowing this, what we can say is that we have a normal distribution with a mean of 585. And the notation for that would look just like this, capital N with a 585 inside parentheses. So this tells us that we have a normal distribution with a mean of 500 and a standard deviation of 85. Shape, center, and spread is all given to us right there in that notation. Now, what if we have a question that says, what score represents the lowest 10%? So this means that we are looking for a particular value of X. We don't know what that value of X is just yet, but we can find it using the parameters of our normal model, z-scores, and this percentage right here. So the first thing we want to do as we go through this PAST is we want to draw a picture. So when I draw this picture, there's a few things that I can put into it. First of all, I'm going to put 500 right there in the middle because that's my mean. I'm going to put X question mark because that's what I'm trying to find. I'm trying to find what value of X will cut off this lowest 10%. And then I'm going to go ahead and shade and label this lowest 10%. Now, in order to do this, there's a couple of different things that I could do, and this leads us to step number 2 in order to find this X. And that is A, which is ask the table or ask the calculator. Now, what I'm asking the table or asking the calculator to give me is a value for my z-score. So that if I can find the z-score, I can then plug in 500 for my mean, 85 for my standard deviation, plug in the z-score value into the formula as well, and then I can solve for X. Well, in the table here, what I see is that the closest value to 10% is right here in the middle at 0.1003. So I've got that 0.1003 circled right there. Now, what is the z-score that goes along with it? Well, the z-score that goes along with it would be starting over here, negative 1.2 and then 0.08. So it would be negative 1.28. So what I'm really doing, let's circle some of these, is this, negative 1.2 and 0.08. That is the z-score that cuts off the bottom 10%, or the z-score that is closest to that. Now, if I was using my calculator, I would want to use a different function. I wouldn't have to use this table. The function on the calculator would be inverse norm, and that's in your second VARS or second distribution menu. So inverse norm for 0.10 is going to give me a z-score of negative 1.2815, which is really close to what we have using the table. So now that we have the z-score, everything else just becomes algebra. So when we use the algebra that we're going to use, or the formula that we're going to use, is the formula for z-score. The z-score formula is z equals x minus mu, the mean, divided by standard deviation. So with that said, what we're going to do now is we are going to standardize everything. So standardize. And when we standardize, we're using the z-score. That's what finding a z-score means. It means we're standardizing our data. So let's go ahead and plug in everything that we know and then solve for X. So here we go. The z-score is negative 1.2815. I could round off to negative 1.28. That would be okay as well. X is what we're trying to find. The mean, mu, is 500, and the standard deviation, sigma, is 85. Then we just do a little bit of algebra, and we find that X is going to be equal to 39.12. The last thing that we need to do once we make our calculation and solve for X is to tell our answer in context. And context is so important. Before I write my answer in context, I actually had a little typo here. This should not be 39.12, it should be 391.2. So I fixed that, and now I'm going to write my answer in context. So the original question said, what score represents the lowest 10%? So my answer should be should be the lowest 10% of students scored at or below 391.2. And so there we have it. You draw the picture, you ask your calculator or table to get the z-score, you standardize by plugging into your z-score formula, and then you answer your question in context. I'm going to quickly go through the rest of these other two examples, and you can follow my work once I get them all filled in. So the second question says, what score represents the highest 5%? So instead of the lowest 10% with the area being to the left, I'm looking at the highest 5% with the area under the curve going to the right. Well, it's important to note that if I'm looking for the value of x that cuts off the highest 5%, that would mean the same thing as the same value that cuts off the bottom 95%. The total area under the curve is 100, so if 5% is over here, then 95% is over here. Well, when you ask your table or ask your calculator, you have to give the value that's under the curve to the left of the value that you're looking for. So if I'm looking for 95% to the left, which is the same as 5% to the right, then I'm looking for 95% in my table. Well, as I look at my table here, what I see is that 95% is directly between these two values. So what I'm going to do is find the average between the two right here and right here. I'm going to average between the two and go with 1.645. That's right in between 1.64 and 1.65. So I'm going to go with 1.645. If I were to use my calculator, I would go inverse norm for 0.95, and that would also give me 1.645. So I'm going to go ahead and now standardize using my z-score. So now when I plug in 1.645 into my z-score formula, I have that there. X is what I'm looking for. The mean is still 500 and the standard deviation is 85. With a little bit of algebra, I can see that X is equal to 639.8. So my final answer in context says the highest 5% of students scored at or above 639.8. Now, what about this last question that says, give me the middle 95% of the test takers? Well, let's take a look and see what that would look like in picture form. When it says, give me the middle 95% of test takers, that means that we're going to cut out the middle 95%. So I actually need to find two values for x, my lower boundary for my lower x and my upper x. This will cut out the middle 95%. Well, if the area under the curve is 100%, then, and 95% is in the middle, that means that 5% has to be in the sum of these two tails. So if I split that in half, because this is symmetric, that means 2.5% is in this tail and 2.5% is in this tail. That's important when I go to my calculator or when I go to my table, because the table or the calculator is always expecting the area to the left of the x value or the score that you give it. So in this case, for this x value or the z-score that I want, I have to put in inverse norm for 0.025 into my calculator, or I can just look at my table and I find that looks like 0.025 is right there, which would be negative 1.96. Now, the nice thing about this is the symmetry of it, because if the z-score that cuts off this bottom 2.5% is negative 1.96, then the z-score that cuts off the top 2.5% is going to be positive 1.96. So I'm going to solve two different equations to find my two different x values. One, the z-score is going to be negative 1.96, and in the other, the z-score is going to be positive 1.96. You can see here that I've set up my two equations, one where z is negative 1.96 and another where my z-score is positive 1.96. And when I solve, I end up getting these two values. Write my answer in context, and I get the middle 95% of students scored between 333.3 and 666.7. I hope this has helped you understand how to use a normal distribution and how to use z-scores a little bit better, along with tables and your inverse norm function on your calculator. And I hope you have fun in your stats class.